We'll proceed in vector algebra and calculus. Vector algebra and calculus, this is the topic that we are pursuing. Vector algebra and calculus. Now we know that vector is nothing very new. People think that vector is very high class. I mean, this is what I used to think. Vector means something that is beyond the brain. So that is called vector. But it is not very much true. Vector is nothing, vector is nothing that is beyond the brain. Vector is nothing but anything with direction. That is the vector. Anything with direction. What is the direction? That is I, J, and K. I don't know what is I, J, and K. Okay, I, J, and K, it looks like very difficult for me, so I cannot understand vector. A person is walking and he is walking from eastward, just consider 45-degree angle. Okay, little bit better. Okay, from eastward, if this is east, if this is east, in this direction it is east, then 45-degree in this direction person is walking. If east from east, if I take 90-degree, then it is north. From east, if I take 90-degree, it is north. From north, if I take 90-degree, then it is west. And from west, if I take 90-degree, it is south and again east. If I say that he is walking in northeast, he is walking in northeast. Oh, east, north, in middle, he is walking. Better, right? Okay, he's walking, he's walking in the northeast, where you consider eastward is 2 and northward is 1. Oh, okay, understood. If this is north and this is east, eastward it is 2. This is eastward 1, northward 1. This direction is what? Because twice component is eastward, one component is north. He's walking more or less in the north, in a sense, 3 times north. This is east and west, same, and then 2, 3. He's walking like this. Okay, now replace east with I vector, that is the x-axis. Replace north with the j vector. Replace west with the minus I vector, and replace the south with minus j vector. He is flying up, means k vector. He is digging the land, then minus k vector. So that is the scenario. This is called vector fundamental. Okay, now if I say he is walking I plus j, then it is alright. I plus j. I means x axis, j means y axis. I plus j means x component and y component is same. East component and north component is same. He is working in I minus j, means x component, east component is x is 1 and south component is 1 minus j, x I minus j, wrong, I plus and in braces minus j. It actually, there is nothing called subtraction, there is nothing called multiplication, there is nothing called division. Okay, everything is addition. So addition is the root of mathematics. Everything begins from addition, ends in addition. So if I say I minus j is working in I minus j, it doesn't mean that I and then minus j. Wrong. Okay. Minus means direction is reverse. If I have, this is what I say. Okay, I get one orange. I get one orange. I get one orange means orange. There is one orange and its direction is this. So if I have x number of orange, then it is x plus 1 because 1 is in this direction. Okay, I lose one orange, wrong. I get one orange in other direction. Okay, so orange is in this direction. Direction of orange is changing. So that is not x minus 1, x plus minus 1. Better in vector term. Okay, so vector is kind of complete mathematics. I plus j. I plus j means it's not I plus j. I, I and j. I minus j. It's not I minus j. I and minus j. Minus j itself is a direction. That is southward. That is symbolized minus j. How someone can say like this? It's not that someone is losing I minus j means minus j gone from I or something like that. Minus j is a separate direction. Uh, Minus I plus j. Minus I is a separate direction at all. That is opposite to I. Minus means reverse. Okay, if I talk about sinusoidal wave like the AC current, alternate current, alternate current, it flow in a sinusoidal way. Means one side it is positive and other side it is negative. Positive, negative. Now people are in dream. What is positive and what is negative? I see current is flowing. Then what is positive and what is negative current? Current is positive and current is negative. Okay, now let's take this is a wire. This is a wire. Now at this point, I have calculated one multimeter, checking the current, right? Now, when I see, I connected a battery and I see current is flowing like this. Okay, all right, it is 1 ampere is a big current. 1 ampere current is flowing like this. Okay, now it is AC wave. AC current is there, that is alternate current. Now if I place multimeter here, then it is showing positive, it is showing negative, positive, negative, positive, negative, zero, zero, some positive and then decreasing and coming to zero and negative. What's going on? Current is flowing in this direction, then current is going back. Negative means reverse direction. So vector is a better way to demonstrate the air AC current rather than sinusoidal. If I say sinusoidal, people go in the air. What is sinusoidal? Okay, so vector in a sense that it is in a function that it current is going. If I put multimeter here, the current will increase. As soon as I collect it, current will increase from zero. The current quantity will grow, means current is growing. It will reach to some level, then current will start decreasing. But current is flowing in this direction only. Okay, then it will come back to zero, no current. Then current will start flowing in reverse direction. Okay, and then again it will reach to a peak value. Then again it will start decreasing, but current will flow in reverse direction. It will reach to zero. Then current is flowing like this. Okay, in any point current is flowing like this. That is alternate current. Why it is like that? This is the science of physics energy. That energy flows in this way only because there is a medium. Consider there is a crowd. Consider you go in some crowd. Okay, any crowd you consider. There is a crowd, there is some fair mela. There is a crowd and you want to cross the crowd. Okay, now you run with a speed and cross the crowd and go that side. Is it possible? If you go with a speed inside the crowd, certainly you are going to hit someone. If you hit someone, if someone feels that you hit him, then he will hit you back. The crowd is called media. That is the median. You are energy. You have to pass through the median. Similarly, if there is a current, current is energy and it has to pass through the iron media, copper media, aluminum media, or air media. Okay, air is also a medium. The current has to pass through that medium. Like a person is passing through a crowd. When he hits the he hits the crowd, then crowd push him back. How come you can hit me? Crowd push him back. Then he goes back. Again because he has to cross, right? Then again he runs. And then he go little inside and hit another person because he made a path, right? He go and hit another person. Now that person again push him back. Okay, again he comes back. Then again he runs and he goes little inside. Push, pull, push, pull, push, pull, push, pull, push, pull, push, pull. Slowly energy starts moving and he crosses the pair. If there was no media at all, then in one go he would have crossed. That is called metal conduction. Like some metal provide better conductivity in the sense resistance is less. If resistance is very high, then he will start doing like this. This way energy is generated in the dynamo because you are forcing energy to be generated in a fashion that there is media and energy gets generated in this fashion only. Okay, so this is the science of vector. Vector talks about the direction. Okay, anyway, I think I have something before we proceed in the vector fundamental. Okay, I believe in the past video we talked about the surface area of the cone. What is surface area of the cone? So surface area of the cone, we found out only surface area of the cone, not the base part. Base part is a circle of the cone and the top part is a cone. Cone is like this and there is a base part circle. What is the surface area of the cone? I believe we saw if the slant line is L and radius of the circle is A, then pi AL. Pi AL is the surface area of the cone. This is what we saw. Area. Area will have width into height. So one direction is A and one is L. So if two get mixed up, then only area will come. In area two length will be there. Area of a circle pi r square, r into r. Two are there. Pi r square. So area of anything will be at least it will have two at least or at most or at that point only. Anyway, so yesterday I was thinking that we talked about right angle cone. Right angle cone in the sense if this is the cone, then this angle is 90 degree. If this angle is 90 degree, then if I put a straight line, then this angle is 45 degree. If it is 45 degree, then this height and this is radius of the circle, radius and this height are same because it is 45 degree. This is 90 degree, this is 45 degree again. So 45 degree, 90 degree means this and this. If this angle 45 degree makes this arc and this 45 degree makes this arc, then they are same. If they are same, if I have a circle like this is cone and this is bottom of the cone that is a circle. On this circle, if I take any point x comma y from center, the distance would be r. R is x square plus y square square root. If that is the case, then height this r, the r and height are same. So equation of height that is z, z is square root of x square plus y square. Okay, because height is same as the radius. If that is the case, then at any moment if height is same as the radius because angle is 45 degree. Okay, in that sense, it is like a right angle cone. Means it is like a z equal to square root of x square plus y square. Okay, what is the generic equation of z fxy for the cone? Okay, I think I can bring, okay, anyway, I will finish it. So if this is the cone, and this base is a circle of radius a, consider this angle is theta. This is not 90 degree theta. If I draw a height h, then this angle is theta by 2. If this is theta by 2, whatever it is. If that is the case, let's tilt the cone like this. The cone is reverse. The apex of the cone is down. This is the cone now. If this is the cone, this is the cone is like this. Earlier the cone was like this. I made it upside down. A cone is like this. If cone is like this, then this angle is theta. If this angle is theta, from center if I draw a height, this is the radius of A. That is the circle of the cone. Now this height is h. This angle is theta by 2. This is full theta. If I take any point x comma y on the cone, on this circle, not on the peripheral, not on the peripheral of the circle, any point x comma y. If I draw a vertical, it will have a z value. From the center, if I draw a vertical, it will have h value, that is the height of the cone. But from anywhere, if I draw, there will be a z value. If there is a z value, then at that moment from base, that point from where I am drawing the height, that point is x comma y. X comma y to base, that is the radius of another circle. What circle is this? If this is the cone and this is the base, and if I talk about z, this is the end apex of z. Here if I cut it, okay, this is the cone at height z, full height is h. At height z, if I cut it, then there is a smaller circle out here of radius r. If that circle, if I talk, then that circle will go and map on this circle. There is a smaller circle r. That circle, if I bring down, then that will be full-fledged circle here that I cut it. The circle is decreasing height by height, and at this point there is no circle at all. But at this point, at the end, there is a big circle of radius small a. So what is r? R is x square plus y square square root any moment. What is the relationship between r and z? Okay, same relationship that is between h and a. So h by a equal to z by r. So z equal to h by a square root h by a into r. So z equal to h by a square root of x square plus y square. That is the equation of the any cone. Any cone equation would be h by a, whatever the height is and whatever the radius is, h by a square root of x square plus y square. We had taken z equal to square root of x square plus y square. That is a special case where h and a are same. Otherwise, it is h by a square root of x square plus y square. If I trying to calculate the surface area, then it is dz by dx whole square plus dz by dy whole square plus 1 square root dx dy. Integration over the circular region of radius a. Then dz by dx whole square, that is h by a dz by dx h by a, and then x by square root of x square plus y square plus h by a. I mean the velocity surface vector. Please watch previous video. So velocity surface vector. Any point if I take on cone P, then P is xi plus yj plus zk. Then velocity vector dp by dx is I plus dz by dxk. Velocity vector dp by dy is j plus dz by dyk. If I make cross product of dp by dx cross dp by dy and calculate the magnitude, it is nothing but velocity surface area. Okay, if I integrate with the xy plane, it will give me the surface area, because integration of velocity gives the distance. Differentiation of distance gives the velocity. So if someone makes cross product of I plus dz by dxk and j plus dz by dyk, someone does cross product, then it is minus dz by dxi minus dz by dyj plus k. Magnitude of this is dz by dx whole square plus dz by dy whole square plus 1 square root, and dxy plane, that is the integration dx dy. Integration over a circular region. If that is the concept, what is dz by dx provided z equal to h by a and then square root of x square plus y square, that is r. Dz by dx is h by a x by square root of x square plus y square. Dz by dy is h by a y by square root of x square plus y square. Dz by dx whole square plus dz by dy whole square plus 1 and square root. If that is the case, then it will become h by h square plus a square into x square by x square plus y square plus h square by a square y square x square plus y square plus 1 square root. Okay, if that is the case, then now if we settle it down, it becomes hx square plus a plus h y square plus a and in bracket x square plus y square. Makes sense? and then divided by a square and x square plus y square. The numerator, if I take h square common, h square x square plus y square plus a square x square plus y square, x square plus y square gone. Now h square, now it remains at h square, I'm sorry, x square gone. Now top remains in h square plus a square, and bottom is a square. If someone take a square root, then it becomes a square root of h square plus a square by a. Now, if this is the cone, and this is height h, and this is a, h square plus a square means the slant line. Slant line is L. So L square by a square, L by a. Done. Okay. So for any cone, when top angle not necessarily 90 degree, any cone, then it is L by a, dx dy, dx dy. And now integration x is minus a to a, y is minus square root of a square minus x square to square root of a square minus x. I am repeating this. This we have already done. Now if I integrate with the dy, then integration will be y minus square root of a square minus x square to square root of a square minus x square to 2 square root of a square minus x square. 2 I can keep outside. Now outside is 2l. L is the slant line of the cone. 2l by a. 2l by 2l by a square root of a square minus x square dx. Integration is minus a to a. If that is the case, then what is integration of a square root of a square minus x square dx? Consider x equal to a cos theta. Then it becomes a sine theta. Square root of a square minus x square becomes a sine theta. And dx would become minus a minus sine theta d theta. Outside is 2l by a. Now here we have minus a square. What we are getting here, minus a square. If I keep it outside, minus a square, then it minus, now outside remaining is minus l into a, minus l into a. And now inside is sine square theta d theta. Integration is theta by 2 minus sine 2 theta by 4. Now here x is minus a to a. X is minus a to a. Someone can settle in the x only. Theta by 2. Theta is cos inverse x by a. X equal to a cos theta. Theta is cos inverse x by a. Now x theta by 2 means cos inverse x by a by 2 minus sine 2 theta. Sine 2 cos inverse x by a by 4. Okay. Now x is minus a to a. So cos inverse x by a. Cos inverse x by a. When x is minus a, cos inverse minus 1. That is cos inverse minus 1 is pi. I'm sorry, I have to start with the numerator. So cos inverse 1, that is 0. Cos inverse 1 is 0. So this is 0. And another is sine of 2 into 0. 2 into 0, sine 0. Full is gone. Nothing remained. Now lower limit is minus a. Cos inverse minus x, cos inverse x by a. Minus a means cos inverse minus 1. Pi by 2. Pi by 2. Pi by 2. Okay. And minus, because lower limit we have to place minus there. So minus, let's minus, and outside minus there, minus gone. Leave the minus completely. Now it is pi by 2 minus sine 2 into pi. Sine 2 into pi. Sine 2 pi gone. Pi by 2. Now pi by 2 into 2 pi 2 L into A. Pi LA. So for any cone, the surface area is pi LA. I tried with the 90 degree, that is the vertical cone angle. Anyway, we will proceed with the vector. This is what we are talking about. So we completed the surface area of the cone. People can try the surface area of a paraboloid. People can try surface area of line length, curve length of sine wave. This is what is under consideration. What is the curve length of the sine length? Dy by dx magnitude dx integration over 0 to pi by 2. This is what is the curve length of a sinusoidal from 0 to pi by 2. dy by dx is cos x, dy by dx sine wave y equal to sine x, dy by dx velocity vector is cos x. Okay, if I calculate the magnitude of cos x, it will, I'm sorry, I'm missing something. Okay, if I sine x, right? If I take any point of the sine x, that point is xi plus yj, xi plus yj. Then dp by dx, that is the velocity vector, that is I plus dy by dxj. That is I plus cos xj. Magnitude is 1 square plus cos x square divided square root. I have to integrate the dx from the 0 to pi by 2. That is the length of sinusoidal curve from 0 to pi by 2. If that is the case, then it would be square root of 1 plus cos square x dx. Someone can try. And there is an elliptical integration. We'll talk slowly. Elliptical integration. I believe it will come in that arena. Same as surface area of a cuboid. So z equal to x square plus y square. Surface area is dz by dx whole square plus dz by dy whole square plus 1 square root. Then in that case, it will become 2x whole square, 4x square plus 4y square plus 1 square root dx dy, where integration is around a circle where if this is a cuboid, then on the xy plane with radius a, that is the region of the limit that we are taking. So x is minus a to a, y is minus a square root of a square minus x square to square root of a square minus x square, and then square root of 4x square plus 4y square plus 1 dx dy. Someone is able to calculate it, then I believe it should be solvable. I believe it will come in a form of a square root of 1 plus kx square, where k is a constant, and 1 is a constant. So m plus n x square root, it will come in this form. So if I divide by m, it will come in the square root of 1 by kx square. Finally, it will come in this form. So that someone can try again. Okay, so we will proceed in the vector. So vector, we are saying anything if we add I and j and k, in that it becomes a vector. If I have an I, if someone is running a distance of 3 kilometer per hour, he is running very slow, 3 kilometer per hour. If I say 3I, then he is running 3 kilometer per hour in I direction. If I say he is running like 3I plus 3j, then he is running at the speed of 3 square plus 3 square square root. That will come as, I believe, 3 square, it will become 3 square root 2. The speed of, if someone says a person is running in direction that is 45 degree from x-axis, or in direction that is I plus j. I mean, you calculate the unit vector, that is the direction. What is the actual run? That is 3I plus 3j. If person is running 3I, means his speed is 3 kilometer per hour in the I direction. If person is running in j direction, 3j, person is running with the 3 kilometer per hour in j direction. Person is running 3I plus 3j. Means person is running 45 degree angle from I axis, and his speed is 3 square plus 3 square root 3 square root of 2. That is the magnitude of the vector, that is 3I plus ij, and that is his speed. What is his direction? Then 3I plus 3j divided by 3 square root of 2. I plus j divided by square root of 2, that is a unit vector, that is his direction. And magnitude is 3 square root of 2. Whoa, what is the speed of the person? Xi plus xj. What was earlier one? 3I plus 3j. That is, that we started with 3 km per hour. How person is running? 3 km per hour. Where he started his run? He started his run in kind of Tehran. He started his run in Tehran. Now he is running at 3 kilometers per hour. I believe I should increase the speed. He is running at 30 kilometers per hour, very high speed, 30 kilometers per hour from Tehran, that is in Iran. He started the run, Tehran, 30 kilometers per hour. Very nice, very nice. Okay, 30 kilometers per hour. How long he will run? He will run for 12 hours. 12 hours. 12 hours means 360 kilometers. Certainly he is going to cross Tehran way, way, way away. In that case, then what is the direction of his run? If he is running 30 kilometers per hour, how long he would run? He would run for 10 minutes. No one would ask direction. Okay, 10 minutes he would run. But if he is running for 10 hours, then anyone would ask the direction. He is running 30 I. Silent. Understood. 30 I means he is going towards Afghanistan. Means there from there he is moving eastward. He is moving towards Afghanistan. 30 I. Okay, a person has started from Tehran and his speed is 30 I plus 30 J. Speed is 30 I plus 30 J. Looks like he's going towards Turkmenistan. Okay, if that is the case, then 30 I plus 30 J. What is his speed? 30 I. 30. No. What is his speed? 30 J. No. Speed is 30 square plus 30 square root of 2. Means 30 into square root of 2. That is his speed. Okay, much faster to the fastest runner from, I believe, from one of the country in Caribbean. I believe he is the fastest runner. So he is Jamaica. So he is fastest to that person. 30 into square root of 2. Okay, that is his speed. So what we are seeing here, numeric that was 30, we added direction. Anyway, now we'll come back. Now at what speed he is running? 3I. What speed he is running? 3J. What speed he is running? 3I plus 3J. Now speed is 3 into square root of 2. What speed he is running? XI. XI. What is X? X is the time. X-axis is the time. He's running at a speed of xi. Means he's running, I is the direction. He's running in I direction. That is true. But his speed is keep on growing as the time is increasing. So he started with the 0. When the time is 1 hour, at that time his speed is 1 kilometer per hour. When time is 15 minutes, then his speed is 1 by 4 kilometer per hour. When time is 2 hour 2 hour 30 seconds, at that moment, this is algebra. At that moment, his speed is 2.5 kilometer per hour. When time is 10 hour, at that time his speed is 10 kilometer per hour. Okay, so person is running at xi. Person is running at xi speed. Means I is the direction in which he is running, but the magnitude is increasing. X is algebra, I is vector, vector algebra, algebraic vector, vector field. This is called vector field. Vector field means a vector whose the component I component j component. Vector is represented as I component j component. The way we are seeing, like if we take east, north, west, south, then any direction will be represented in. This is what is, at least in India, the direction of anyone when he is walking. It is termed in this fashion only: east, north, west, south. How, where he is going? He is going eastward, little bit northward. This is what it is. Same thing now, someone put in ij minus I and minus j. That's it. So if someone is saying that his direction, what is the vector direction? Vector direction is combination of this component, east component, north component, something like that. So I plus j, and but if the, what is the ith component? 1. If I say I plus j, what is ith component? 1. What is the jth component? 1. If I say xi plus xj, xi plus xj means the, if this is x-axis, he's moving in xi plus xj, means j is this is y-axis, this is y-axis, this is y-axis, and this is x-axis, this is x-axis. Now he's moving in this direction, that is xi plus yj, because at any moment it has x component also and it has y component also. At any moment it has I component also, j component also. Xi plus xj. I'm not saying yj. Xi plus xj. Xi plus xj. That is his velocity. Velocity is x square plus x square square root. That is the magnitude of the velocity. Direction is xi plus xj by x square root of 2. That is I plus j by divided by square root of 2. Makes sense, right? So vector talks about direction and vector talks about the magnitude. With this, we have already seen, we calculated the curve length, we calculated the surface area. Now we are going to calculate the work done. Work done, but this is big thing. It is not that small. Work done, if I have a, oh, okay, there is a force already here. I am not sitting actually. I am not sitting actually. Someone is pulling me. Okay, actually, I'm trying to stand. If I try to stand, then I am going in reverse of some force that is already there. That is called earth gravitational pull. That is a force. That force is trying to pull me. Okay, means if consider there is a force like this. If I keep an item here, then it will displace it. The force is in this direction. I had one magnet. Okay, so I have one magnet and I need to have one one iron. Okay, so this is a magnet. Okay, this is crooked one. So this is the magnet. If this is the magnet, then I have, okay, I believe this is certainly one iron piece. Okay, oh no, this is the magnet. If I try now, this is the iron piece. Oh, connected. So this magnetic force is in this direction. When iron comes in touch of magnet, okay, so it sticks. The iron, if I want to take it, I have to apply force. But if I keep it, it goes there only. Just so this says that, this proves that who is working here? This magnet is working here. Magnet has a force, and if I apply something with force, it attracts. But if I keep doing like this, okay, very nice. I understood. If there is a magnet and if I do like this, then it attracts. Look, this is not the end of the story. If you keep doing like this, magnetic field will go away. After some time, it won't attract. Why it won't attract? This is the nature of the magnet, right? This is the nature of the magnet. If you put a iron near to the magnet, it attracts. Okay, keep doing it. One time, two time, 100 time, 200 time. After that, if you give the iron, it won't attract because it is working. It is losing. Working means energy. It is working. If this is the magnet, if you put like this, then it is attracting. It is working. This magnet is working. If it is working, that's why it is attracting. Means if you are saying working, means there is energy, right? Yes, it is losing energy. With that energy, it is pulling. If it keeps losing, then one time will come, there won't be any magnetic field. How much energy it is losing, or how much work done it is doing. Like if I work day, I feel hungry because I have lost energy, right? Like that, if I consider this is not the magnet, this is me. And if it is like this, I pull it. Then if it is like this, then I pull it. This is my hand. Then again, if I keep doing like this, then I'll say I need a juice or I need some energy drink. Like that magnet also. If you keep pulling, then it is losing the energy. If Earth is if Earth is doing this for millions of years, This proves that Earth is gaining the energy from somewhere. Otherwise, Earth magnetic pull would not be there. Like Sun or means Sun and every planet, they are receiving energy from somewhere. That's why they are working day and night, day and night. Earth is working day and night. So Earth is not only rotating around the Sun, Earth is not only rotating around its own axis, Earth is attracting also. So everywhere energy is lost, right? In that sense, one is magnetic, one is kinetic, and all. Energy is only one. There is no magnetic and kinetic and potential. Energy is energy. These are the forms of energy. Means Earth is keep on getting energy. This proves like that. But this magnet will not keep on getting energy, and it will lose. How much is the work done by the magnet? If I know that magnet has this much energy inside it, and if I know that in one pull, how much is the work done by the magnet, then I can say that this many pull is magnet is going to do. After that, it will go away. So work done. First of all, what is work done? Work done is force into displacement. If Earth has a force, and if I know the displacement, then that much work is done by the Earth. So if I live like this, then it drops, right? Then force, whatever the earth forces into this much displacement, that much the work done by the earth, that much energy earth lost, that much energy earth lost. So work done. Okay. Now consider I make a line that is round the earth. Okay, if I live like this, now from here I make a circular line. I make a circular line around the earth, one big circle around the earth. On that circle, I just insert it. Okay, there is a fine wire is there that around. In that I insert it. It will not move. Okay, but but consider consider this is a consider this is a circle. If I insert this inside the circle, then it will drop. It will drop. But if this circle is so big that it covers the full earth, and then you put inside it, it will not move. Okay, but it should move, right? Somewhere it should slide, right? If I put here, if this circle is small, and if I insert this is a bolt, huh? This is a bolt, okay, or nut, whatever it is, there is a hole inside it. If I insert it and just leave it, it will drop like this and it will stand here. If the circle is very, 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 very big and it covers the full earth like this, and there, if I place this, it will not move. Earth gravitational pull will not work at all. It will not move. But if the circle is small, 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 this much, it will move. Why it is? Okay, so we will go more in the energy and the vector. It means that if it is not moving, means Earth is not losing energy on you. Okay, if there is a magnet and there is a iron and magnet is not attracting it, means magnet is not losing energy on you. Is there really a possible that magnet would not lose energy even if iron is there? How come it's possible? Not possible, right? If magnet is there, iron is there, then magnet will attract it. Not possible every time. There are chances it will not attract it because there is a way, something called direction. There is something called direction and work done. Okay, we will see it. What is work done, what is energy, what is the direction rule. Because just I say earth is there and item is there, earth is pulling, not required. Every time earth will not pull it because there is something called vector comes into the interesting, right? It is amazing. Like if you make a ring around the moon, a ring around the moon, and place something in the ring, then moon would not attract it. Something like that. Okay, if that is moving along the, I mean, is it all right? It is all right, right? Okay, we'll talk about it. Isn't it you're talking about satellite moving around the planet or Earth, something like that? Yes. So those fundamental we will talk all comes in vector fundamental. So that we will see. Please do support us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code. Mind blowing vector fundamental.